Distillation is an extraction technique used to extract a molecule of interest from a solution by utilizing its boiling point. A molecule's boiling point is governed by its structure and the intermolecular forces it's able to employ. In this experiment, ethanol was extracted from water. Ethanol is a polar organic molecule with a dipole moment of 1.7, which is close to water's 1.8 dipole moment. Ethanol can also hydrogen bond, and like all molecules, it has dispersion forces. These characteristics gives ethanol its 78 degrees Celsius boiling point and makes it miscible with water. Because ethanol has a lower boiling point than water, it is more volatile and therefore will make up most of the vapor of the solution. Ethanol was extracted with both simple and fractional distillation. The difference between simple and fractional distillation has to do with the number of times the vapor condenses and evaporates before it becomes the distillate. In simple distillation, the vapor only condenses once before it becomes a distillate, whereas in fractional distillation, the vapor condenses and evaporates multiple times before it becomes a distillate. This is accomplished by adding a distillation column filled with glass beads between the distillation head and the round bottom flask. The surface of the glass beads is what causes the vapor to condense and evaporate multiple times as it moves up the distillation column. By the time the vapor reaches the distillation head, it would be richer in ethanol compared to simple distillation, and then it will condense and become the distillate. For both simple and fractional distillation, the temperature was recorded for every corresponding 0.5 mils collected of the distillate. With the data collected from the experiment, a line graph was made with temperature versus volume. The blue line represents simple distillation, while the red line represents fractional distillation. And as you can see, there's a notable difference between simple and fractional distillation just by looking at the line graph. In fractional distillation, the vapor temperature seems to stay around 77 degrees Celsius, but then rises rapidly when about 13 mils of the distillate was collected. While in simple distillation, the temperature rises steadily and then rises up rapidly around 13 mils as well. Because both lines started rapidly rising around 12.25 mils, we could find the percent concentration of ethanol within the solution. In both simple and fractional distillation, 20 mils of the solution were added to the apparatus. And so if 12.25 mils of ethanol made up those 20 mils of the solution, you could divide that by 20 mils, then multiply it by 100% to get the percent concentration of ethanol in the 20 ml solution, which will be 61.25%. An unavoidable error of the experiment is the fact that water will vaporize from the solution and make its way into the distillate, making ethanol diluted. This happens because when ethanol is mixed with water, a solution is made, a solution that has a vapor pressure. Since water and ethanol both evaporate at room temperature, both of them contribute to the solution's total vapor pressure. However, ethanol will make up most of the vapor because it is a more volatile molecule of them both. So as distillation is carried out, the majority of the molecules that are being extracted is ethanol. But it's important to note that water will also make it into the distillate. This error could be minimized in fractional distillation, where the vapor is condensed and evaporated multiple times, each time making the vapor richer in ethanol. But there will still be some amount of water that makes it into the extracted distillate. An avoidable error occurs when distillation is carried for too long. If extraction of a molecule is of utmost importance, then distillation has to be stopped before the distillate starts to be made up of other molecules that aren't supposed to be extracted with distillation. The first distillate that is received in distillation is always richest in the molecule of interest that's supposed to be extracted. But as distillation is carried on, the distillate becomes more diluted of the molecule of interest because other molecules are making it into the distillate.